everyone, we are Carbon Crusher Club, and today we'll be presenting Decoding the Path to Net Zero, a data-driven journey into global CO2 mitigation. Let's get started. In the fight against climate change, various global mechanisms ranging from carbon capture technologies to carbon pricing and voluntary offsets are being employed. This presentation delves into 5 key datasets to extract insights on CO2 emissions, mitigation strategies, and market mechanisms. By comparing carbon capture initiatives, carbon offsets, emissions trends, and carbon market data, we aim to provide a comprehensive understanding of how different strategies contribute to reducing global warming. Our analysis highlights the disparities in national approaches to carbon mitigation, the role of technological advancement in energy efficiency, and the future trends in carbon pricing and revenue growth. These 2 plots showcase different approaches to CO2 mitigation across regions. The first plot reveals that CCUS projects are concentrated in developed countries, particularly the US. The second plot, however, shows a more global distribution of voluntary carbon offsets, with significant contributions from India, Brazil, and Kenya. This contrast reflects the differing strategies for CO2 reduction. Developed nations invest in capital-intensive technologies like CCUS, while developing countries leverage the voluntary carbon market. Wealthier nations tend to adopt high-tech solutions, while developing regions make use of market-based, accessible approaches. These diverse strategies highlight the global need for both technological and market-driven methods to address emissions. A key takeaway from this plot is the relationship between population and CO2 emissions. We see a high correlation between total CO2 emissions and population, as more people means more energy consumption, driving overall emissions higher. However, the weak correlation between CO2 per capita and CO2 emissions tells a different story. This reflects the wide variation in energy use between countries. In developing countries, CO2 per person tends to be low, even with large populations. Conversely, in wealthier nations, a smaller population may produce far more CO2 per capita. Land use change CO2, from deforestation and agriculture, has a lower correlation with temperature change than fossil fuel emissions. While land use changes contribute to emissions, their impact on global temperature is less direct, highlighting the need to prioritize industrial and transportation emissions in climate policy. Additionally, land use change CO2 per capita shows almost no correlation with temperature change or total CO2, suggesting that its effects are more localized rather than having a global impact. The plot shows that CO2, orange line, has the largest impact on global temperature, primarily due to fossil fuel combustion. The overall GHG, green line, also rises rapidly, reflecting CO2's dominant role among greenhouse gases. Methane, CH4, and N2O have lower impacts, with methane largely from agriculture and fossil fuel extraction, and N2O from fertilizers. Land use change CO2 has less impact because it involves methane and N2O, which contribute less to warming compared to fossil fuel CO2. These plots show that energy, fugitive, and fuel emissions have a steady positive correlation with temperature change, as rising emissions contribute directly to global warming. However, we observe a reduction in CO2 per total energy supply, which suggests that the world is becoming more energy efficient and adopting cleaner energy sources like renewables and nuclear power. This reflects technological advancements and more efficient energy production. On the other hand, CO2 per population remains relatively stable. This is because the higher energy consumption in developed countries is offset by the lower energy use in developing countries, where populations are growing faster but consume less energy on a per capita basis. This keeps global CO2 per population within a narrow range. This chart compares industries based on profitability and environmental impact, emissions. Sectors like construction in the top left generate high profits with lower emissions, while mining and oil and gas in the bottom right produce high emissions with varying profitability. It helps assess which sectors efficiently convert emissions into profit and which need improvement in terms of environmental or business efficiency. Scope 1 and 2 emissions, direct company emissions, differ from Scope 3 emissions, indirect emissions from suppliers and product life cycle. For example, oil and gas has high Scope 3 emissions due to the extensive use of its products, though its direct operations, Scope 1 and 2, may be more efficient. In this plot, we observe a weak negative correlation. Higher carbon prices don't necessarily result in more offset projects issuing credits. In fact, there may be a slight decrease as prices rise. Outliers: one country issues an unusually high number of credits at a relatively low price, under $20 per ton CO2 equivalent, which affects the overall trend. Flat distribution: most countries cluster in the 0 to $40 range with low credits issued, and even when prices increase, credits issued remain close to zero. This indicates that factors beyond carbon pricing, like policy, market demand, and project availability, likely play a larger role in driving offset credits. In summary, higher carbon prices alone aren't a strong driver for carbon credits, with other variables having more influence. Looking at this visualization, globally, only 33 countries have both carbon pricing and voluntary offset mechanisms. China leads in issuing offset credits, despite having a low carbon price, showing its ability to scale projects effectively. Meanwhile, Switzerland and the UK have high carbon prices but issue fewer credits, possibly due to a focus on other emission reduction strategies or barriers to offset project development. The United States stands out with both a high carbon price and strong offset credit issuance, balancing market mechanisms with project development. These differences highlight the diverse strategies nations use in their carbon mitigation efforts, with some focusing on other solutions beyond offset credits. As we look at these forecasts for carbon revenue and price, there are some key insights to highlight. First, carbon-related revenue has grown steadily in recent years and is expected to surge by 2030, indicating the growing adoption of carbon pricing mechanisms and stronger climate regulations. On the other hand, we see that carbon prices have historically been volatile, but are projected to increase significantly after 2025, reflecting the mounting pressure to reduce emissions and meet climate targets. This price rise will particularly affect high-emission industries, pushing them towards greener technologies and energy efficiency measures. Overall, these trends suggest that carbon markets will play a critical role in financing the global transition to a low-carbon future. In conclusion, our analysis reveals several important trends in the global effort to mitigate climate change. Developed countries are focusing on carbon capture technology, while developing nations rely on voluntary carbon markets. Emissions from fossil fuels are the key driver of global warming, as shown by their direct correlation with temperature changes. While land use changes have a more localized impact, carbon pricing mechanisms and offsets are expanding, yet they reveal significant geographic disparities, with only 33 countries actively participating. As carbon pricing continues to rise, forecast models suggest a growing financial push for industries to adopt greener practices. These insights emphasize the critical need for global collaboration, innovative energy policies, and market-driven mechanisms to achieve long-term sustainability and combat climate change. And this concludes our presentation. Thank you.